Now that we have a good grasp on what it means to solve an equation, and we're comfortable solving simple equations, we can start to think about solving more complicated equations. Recall that a one-step equation contains only one variable, which appears once, and only a single operation. So for example, the equation x plus 4 equals 7, or 2x equals 8 would be two examples of one-step equations. The next simplest sort of equation is what's called a two-step equation. This still contains only one variable, which still appears only once, but now it contains both multiplication and addition. An example of such an equation might be the equation 2x plus 3 equals 11. Notice, with one-step equations, we can often easily guess the solution just based on the arithmetic facts that we know. With two-step equations, this is a little bit harder. We're more likely to actually need to apply the properties of equality in solving a two-step equation. To solve a two-step equation, we need to keep our goal in mind, and that is to obtain an equivalent equation of the form x equals a number. So to solve the equation 2x plus 3 equals 11, we will need to get rid of this constant that's added on and get rid of this coefficient that we're multiplying by. From our experience with one-step equations, we know how to get rid of a term, and we know how to get rid of a coefficient. To get rid of a term, we add its opposite. Sometimes we'll want to think of this as subtracting. To get rid of a coefficient, we multiply by its reciprocal. Sometimes we'll want to think of this as dividing. So in solving a two-step equation, the important question to ask is, what should we deal with first? Let's see this both ways and see which one seems easier. First, I'm going to try getting rid of the 2. In order to do that, I'll need to multiply both sides by 1/2. So I'll have a half times 2x plus 3 equals a half times 11. To simplify the left-hand side, I'll need to use the distributive property. A half times 2 is 1, so I just have x plus a half times 3 is 3 halves equals 11 halves. And now all that's keeping x from being by itself is the 3 halves. This is a term, so I want to add its opposite. I'll have x plus 3 halves plus negative 3 halves equals 11 halves plus negative 3 halves. 3 halves plus negative 3 halves is 0, so on the left I'm just left with x. On the right, I have the same denominator, so 11 plus negative 3, I have 8 halves, which is just 4. So I get the solution x equals 4. And I can check that by saying 2 times 4 plus 3, that equals 8 plus 3, which really is 11. Okay, what if instead of that, I had chosen to get rid of the 3 first? So starting again with 2x plus 3 equals 11, I'll add negative 3 to both sides. So I have 2x plus 3 plus negative 3 equals 11 plus negative 3. 3 plus negative 3 is 0, so I'm left with just 2x. 11 plus negative 3, that's 11 minus 3 is 8. And now I'll get rid of the 2 by multiplying both sides by 1/2. So I'll have 1/2 times 2x equals 1/2 times 8. 1/2 times 2 is just 1, so I just have x. 1/2 times 8 is 4. So again, I get the solution. X equals 4. Okay, what have we discovered? In answer to our question, what should we deal with first? The first thing we've discovered is we can actually do whatever we want first, as long as we're careful. However, notice how when we choose to multiply first, we need to distribute, whereas when we choose to add first, the actual steps involved are a little bit easier. Therefore, we will always choose to get rid of the constant term first, and then the coefficient, because this makes the steps easier. So if I wanted to solve the equation negative 2x plus 5 equals 1, I would first add negative 5 to both sides. So negative 2x plus 5 plus negative 5 equals 1 plus negative 5. 5 plus negative 5 is 0, so I'm left with negative 2x. 1 plus negative 5 is negative 4. Now I want to get rid of the negative 2x, so I'm going to multiply both sides by negative 1/2. I have negative 1/2 times negative 2x equals negative 1/2 times negative 4. Notice again, negative 1/2 times negative 2 is just 1, so I'm left with just x. Negative 1/2 times negative 4 is positive 2. I get x equals positive 2 as my solution. Again, I might want to check that this really worked. Negative 2 times 2 plus 5. Negative 2 times 2 is negative 4 plus 5 equals positive 1, which is what I hoped to see.